Hello. Welcome to the previous year questions, solution of previous year questions from the subject Engineering Hydrology. Today we'll look at the questions from Runoff and Hydrographs, and this is the part 8. So here we'll see primarily the questions from the year 2017. Uh, so the first question is: an effective rainfall of 2 hour duration produced a flood hydrograph peak of 200 meter cube per second. So the peak of flood hydrograph is given. So this is our first information. Peak of flood hydrograph. So Q peak of flood hydrograph is given, that is 200 meter cube per second. The base flow is given. So the base flow is given to us, which is 20 meter cube per second. Right. Now, the next information is given is the special average rainfall in the watershed for the duration of storm is 2 centimeter. So, precipitation is given to us. Special average precipitation is given to us, that is 2 centimeter of rainfall has occurred over the catchment. And average loss rate is given, which is nothing but the phi index. So, the phi index is, which is average loss rate, that is equal to 0.4 centimeter per hour, right? And the question is, we have to calculate the peak of 2 hour unit hydrograph, right? So base flow is given, flood hydrograph peak is given. So from these two information, we can calculate the peak of what, DRH, which is nothing but peak of flood hydrograph minus base flow. That means 200 minus 20, which is 180 meter cube per second. Right. So this is the peak of DRH. Now question is, you have to calculate the peak of 2 hour unit hydrograph. So what is the relation between DRH and unit hydrograph? So peak of unit hydrograph is nothing but peak of DRH divided by what? Effective rainfall. Correct. So is divided by effective rainfall. So what is effective rainfall? Effective rainfall is equal to rainfall minus phi index multiplied by the time. Correct? Because phi index is equal to precipitation minus runoff divided by time. Correct? So from here, effective rainfall will be is equal to 1.2 centimeter. That means, so this is 180 divided by 1.2, which is nothing but is equal to 150 meter cube per second. So option C. Next. So there is a rainfall intensity is given to you. During a storm event in a certain period, rainfall intensity is 3.5 centimeter per hour. So rainfall intensity I is given as 3.5 centimeter per hour. What is rainfall intensity? I is nothing but precipitation, total precipitation divided by time, right? So अगर 4 घंटे में 20 सेंटीमीटर रेनफॉल होता है, that means intensity is equal to 20 divided by 4. That means 5 centimeter per hour. This is what intensity means. So intensity is given, phi index is given to you. Phi index is equal to 1.5 centimeter per hour. The intensity of effective rainfall. What is intensity of effective rainfall? If you look at the graph, this is your rainfall intensity. Okay, these are your rainfall intensities. If you look at the phi index, this is your phi index, right? This is phi index and this is your rainfall intensities. ठीक है, फाइ इंडेक्स के नीचे क्या होता है? फाइ इंडेक्स के नीचे दिस इज योर इनफिल्ट्रेशन, दिस इज योर इनफिल्ट्रेशन और लॉसेस, और इसके ऊपर जितना होता है दैट इज योर व्हाट, इफेक्टिव रेनफॉल और रन ऑफ, इफेक्टिव रेनफॉल स्लैश रन ऑफ, right? So what is the effective rainfall here? Effective rainfall is equal to what? 3.5 minus 1.5, which is equal to 2 centimeter per hour. Option B. Very simple, right? So as you can see, the questions in GATE that are asked, these are not very difficult, but your concept has to be very clear. Or agar the videos are helping you in any way to practice the concepts, to understand the topics, then please do subscribe to our channel, like these videos, share these videos, and if you have any question, please do write in the comment box. Uh, if you support our initiative, then हम लोगों को भी will also get the encouragement to create more and more videos, because it's a very hectic task, to record this and to upload this. So your support and your appreciations will always be helpful to move forward. Let's look at the next question. तो यहाँ पे आपको इन्फिल्ट्रेशन कैपेसिटी दिया हुआ है, राइट, which is F C1 plus C2 e to the power minus k into t. ठीक है, what is the actual formula? First let us look at the actual formula. क्या होता है actual formula? Fc plus F naught minus Fc e to the power minus kt. ये होता है actual formula for infiltration, Horton's curve का जो actual formula होता है. What is given to you? The initial infiltration capacity. Initial infiltration capacity is F naught, 200 mm per hour. What is FC? 25 mm per hour. ठीक है, तो C1 क्या होगा? C1 is FC, that means 25. So 25 plus what is C2? C2 is nothing but F naught minus FC. So 200 minus 25 e to the power minus k t. एक घंटे के बाद after 1 hour duration, F is given as 90 mm per hour, right? So एक घंटे के बाद infiltration is 90. So 25 plus 175 e to the power minus k into 1, right? So from here you can calculate the value of k, and k will be equal to, what will be the value of k? E to the power minus k is equal to then 65 divided by 175, right? So both side you take log or ln base e. This is also take ln, and the value will be your 0.99. Okay. Right. So let's look at next question. Similar questions was asked, but here as you can see in the equation, the only difference from the previous question is F is given as 30 plus 10 into e to the power minus 2t, right? So this is the equation of the Horton's curve which is given to you. What is the question? The total depth of infiltration during last 20 minutes of storm of 30 minutes duration. 30 मिनट का रेनफॉल हुआ है, right? And in last 20 minutes what is the total infiltration that you have to calculate, right? So the storm duration is how much? 30 minutes. Within that 30 minutes, in last 20 minutes, how much rainfall has happened, that you have to calculate, right? So that means after, suppose if the rainfall starts here, and this is the 30 minutes duration, 0 to 30, okay? So you have to start your calculation from here, 10 minutes. So during this period, how much infiltration has taken place, that you have to calculate. But T is in hour, right? So 10 minute we have to convert in hour, 1/6 of an hour. This is half of an hour. Okay. So what is the total infiltration? F is nothing but integration. What is the limit? 1/6 to 1/2. 30 plus 10 into e to the power minus 2t into dt. So now if you solve this, the answer will be 11.75 mm. Just solve this definite integral and you will find the value. Let us look at the next question. Total rainfall in the catchment area is total rainfall in a catchment area 1000 square kilometer during 6 hour storm is 19 centimeter. So catchment area is given to you, that is 1000 square kilometer. Okay. Total rainfall is given, that is 19 centimeter. Okay. So surface runoff, total surface runoff is given to you. Total surface runoff is 10 to the power 8 meter cube, right? So phi index you have to calculate. Okay. So runoff volume is given. So what is the runoff depth? This is the runoff volume. So what is runoff depth? Depth is nothing but runoff volume divided by catchment area. 1000, you have to convert this into centimeter. You have to convert this in meter, which is nothing but 0.1 meter or 10 centimeter. What is phi index? P minus R divided by T. Duration of the rainfall is given 6 hour. P is 19 minus 10 divided by 6. So 1.5 centimeter per hour. Okay. So with this, we will conclude today's video. If you're liking this series, once again, please do subscribe to our channel and we'll come back shortly with the next part, part 9. Thank you so much.